understand the journey of the banana, one must first understand that what we eat is a biological anomaly. Every single Cavendish banana found in supermarkets across the United States, Europe, and Asia is a clone. They are genetically identical copies, propagated from cuttings rather than seeds, originating from a single mother plant. This genetic uniformity allows for the massive industrial scale of production we see today, but it also dictates every single step of the farming process. We begin our journey in the equatorial belt, regions like Ecuador, Costa Rica, and the Philippines, where the combination of volcanic soil, high humidity, and 12 hours of sunlight creates the perfect incubator for this green gold. The banana plant itself is a marvel of nature. It is not a tree, but the world's largest herbaceous plant. It possesses no woody trunk. Instead, its pseudostem is formed by tightly packed layers of leaf sheaths that push upward from a rhizome bulb, reaching heights of 20 feet in just 9 months. The harvest is a high-stakes operation that relies heavily on human skill and intuition. Technology has yet to invent a robot capable of navigating the muddy, uneven terrain of a jungle floor while possessing the delicate touch required to harvest this fruit. Teams of workers, often with generations of experience, patrol the endless green corridors of the plantation. They are hunting for a specific set of criteria. They check the caliper width, the thickness of the individual banana fingers, and the specific hue of green. If a bunch is harvested even 3 days too late, the fruit will begin to produce ethylene gas. This invisible hormone can trigger a chain reaction, causing the entire bunch to ripen and rot during the long ocean voyage, potentially spoiling thousands of dollars worth of cargo in a single shipping container. The harvesting process is a synchronized dance between two specialized workers, the cutter and the backer. The cutter uses a razor-sharp machete attached to a long pole to reach the top of the plant. He makes a precise, calculated incision into the pseudostem. The massive plant, unable to support its own weight, slowly collapses. This is the critical moment. The backer must step in and catch the falling bunch on a thick, foam-padded cushion resting on his shoulder. These bunches can weigh between 80 to 110 pounds. The catch must be incredibly gentle. At this green stage, the banana is full of water and extremely brittle. A hard impact against the worker's shoulder or a drop to the ground will cause the internal cell walls of the fruit to burst. This damage is invisible to the naked eye in the field, but 2 weeks later, it will manifest as a black, mushy bruise that renders the fruit unsellable. Once the bunch is secured on the backer's shoulder, the cutter slashes the rest of the plant down, leaving it to decompose and fertilize the soil for the next generation. The backer then walks the heavy load to the cableway. This is the circulatory system of the modern plantation. Miles of steel cables are strung through the jungle, suspended from metal arches. The workers hook the heavy bunches onto this overhead rail system using color-coded ribbons that indicate the harvest date. It looks like a slow-moving train of green fruit floating through the forest. A single worker, using a towing harness, can pull a train of 20 to 50 bunches, weighing nearly 5,000 pounds, gliding effortlessly toward the packing house. This cableway system is crucial because it ensures that from the moment of harvest until they are packed, the bananas never touch the ground, protecting them from soil-borne bacteria and physical trauma. As the fruit arrives at the processing facility, the environment shifts from the organic chaos of the jungle to the stainless steel precision of a factory. The first and most important step is the dehanding and washing process. The bunches are immediately unhooked from the cableway and plunged into a massive receiving tank of water. This water bath serves two purposes. First, it cools the fruit, removing the field heat accumulated under the tropical sun. Second, and more importantly, it combats the banana's natural defense mechanism, latex. When the plant is cut, it bleeds a sticky, milky white sap. This latex is rich in tannins and oxidizes instantly on contact with air, turning into a permanent, ugly black stain. If this sap drips onto the peel, it ruins the visual appeal of the fruit. The water in the tank stops the bleeding by constricting the plant's vascular system and washes away any flowing latex. Workers stand waist deep in these tanks, using curved, razor-sharp knives to slice the hands, the clusters of 5 to 7 bananas, off the main central stalk. The stalk is crushed and recycled, while the separated hands float gently down a man-made river system. This water canal utilizes the physics of buoyancy to transport the fruit without friction or pressure, drifting them silently toward the packing tables. As the bananas emerge from the water canal, they are clean, cool, and free of latex. Now they face the rigorous inspection of the quality control team. The standards for export-grade bananas are notoriously strict. Inspectors examine every single finger for the slightest imperfection. A scratch from a leaf rubbing against the fruit in the wind, a scar from an insect, or a shape that is too straight or too curved can lead to rejection. Approximately 15 to 20% of the harvest is culled at this stage. These rejects are perfectly edible and taste exactly the same as the premium fruit, but the global market demands visual perfection. These culled bananas are diverted to local markets or sent to processing plants to be turned into baby food puree or flour. The chosen survivors continue down the line to the treatment station. Here, they are passed through a spray tunnel where they are coated with a fine mist of food-safe fungicide and alum. This step is non-negotiable for international trade. The crown of the banana hand, the fibrous tissue where it was cut from the main stalk, is essentially an open wound. Without this protective treatment, mold spores would enter the crown during the humid ocean voyage, causing crown rot, a fungal infection that turns the top of the banana into black mush. Following the treatment, high-speed pneumatic labeling machines apply the brand stickers, the blue or yellow badges of Chiquita, Dole, or Del Monte, faster than the human eye can follow. Packing the bananas is a lesson in geometry. Workers assemble heavy-duty cardboard boxes designed with specific ventilation holes to allow airflow. Inside the box, they place a specialized plastic liner. This is not just a bag, it is modified atmosphere packaging, or MAP. Workers arrange the banana hands in a specific interlocking pattern to maximize density and ensure stability during transport. Once the box is full, a machine vacuums the air out of the plastic bag and hermetically seals it. By removing the oxygen and allowing the carbon dioxide generated by the fruit to build up within the bag, the metabolic rate of the banana is slowed down to a near halt. The banana enters a state of suspended animation, a biological coma. This technology, combined with refrigerated shipping containers kept at a precise 13.3 degrees Celsius or 56 degrees Fahrenheit, allows the green bananas to survive a voyage of up to 4 weeks without ripening or rotting. However, the journey does not end when the ship docks. The bananas arrive at their destination still rock hard, green, and full of starch. To make them edible, humans must intervene in the biological process. The pallets are transported to commercial ripening rooms. These are high-tech, pressurized gas chambers capable of holding thousands of boxes. The room is sealed, and the temperature is gently raised to simulate a tropical environment. Then, the ripening master injects a precise amount of ethylene gas into the room. Ethylene is a natural plant hormone. It is the signal nature uses to tell a fruit to ripen. In the wild, the plant would release this gas slowly. Here, we force feed it to the fruit in a controlled burst. This triggers a rapid and complex chemical cascade within the fruit. Enzymes are activated that break down the rigid pectin cell walls, softening the flesh. The chlorophyll in the skin degrades and vanishes, revealing the yellow carotene pigments that were hidden underneath. Most importantly, the starch converts to sugar, giving the banana its sweetness. The facility can control this process with godlike precision. They can ripen a banana in 4 days for a rush order, or stretch it to 7 days for a longer shelf life. The bananas leave the ripening room usually at stage 4, yellow with green tips, perfect for shipping to grocery stores. But there is another destiny for the green banana, the chip factory. For banana chips, the ripening process is skipped entirely. Green bananas are preferred for their high starch content and structural firmness. Machines use friction rollers to peel the tough green skin, a task that is incredibly difficult for human hands. The naked white fruit is sent through high-speed rotary slicers, turning them into uniform coins. These slices rain down into industrial fryers filled with coconut oil heated to 350 degrees Fahrenheit. The intense heat flashes the water out of the cells instantly, locking the starch into a crispy structure before it can turn to sugar. The chips are then tumbled in drums with honey, salt, or spices. From a clone in the muddy jungle to a gas-induced awakening or a deep-fried snack, the industrial life of a banana is a testament to humanity's obsession with controlling nature to feed the world.